Guys, so welcome back to my channel, and for today's video it will be about GCE A levels P3 paper, A levels P3 syllabus, and we are talking about iterations. Okay, so without wasting any time, let's jump into this topic. Okay, so what is iterations about? So iteration is basically um, a solution or a method to find a root using repetitive calculation. So let's say for an instance, I'm just giving an example. We're given the formula to find a root, where the formula is this is just an example, by the way. A square 1 plus a square. It's just an example. So to find that root of a specific graph, we have to keep repeating this the calculation using this formula with the value of x we found before. So that's why we see most formulas are written as xn plus 1. Sorry, xn, because the thing is, whatever value that is subbed in here is the value that is found in the previous calculation. So for example, to find the 8th iteration, we will use the value of the 7th iteration, the value of the 7th iteration. Okay, so that's basically what iterations is. So it's finding the root of an equation by repeating each calculation with the previous values, and this will be xn. So this xn will be subbed into here to find what is the next possible root. Okay, so each calculation brings us closer to the actual root of an equation. So like just what I mentioned, over here we are repeating the calculation using the iteration formula to get us closer to the real root. And there'll be a certain point where that iteration becomes constant. It doesn't change anymore. The value of xn plus 1 does not change anymore. And this tells us that we have arrived at the value of the root. So when no changes, we are at the root, the actual root. Okay, so that's what it is. All right, and we will jump into a few questions later for to understand about iterations more better or more in depth later on. Okay, so another part of this topic, you could say, based on the questions they ask, is about proving a root. Okay, proving a root if it lies between two specific x values. So you can have questions asking, prove that the root of this equation, I don't know, let's just say y equal to fx, all right? Y is equal to fx, all right? So they're going to ask you to prove that the root of this equation lies between two specific points. Okay, and how do we actually prove that? So we actually prove that by subbing the x value of the first limit that is given into the equation, okay, and find the answer for that, and sub the second value that is given, for example 2.0, into the equation to give us the next value. Well, the catch is, when you sub the first value, when subbing in the first value, we could get a positive or negative answer, or product, you could say. However, when we sub the second value, we will get the opposite sign. And what I mean is, if the product of the first value is a positive, let's say it's a positive, the second one would be a negative. Or if the first one was a negative, the second one would be a positive. Okay? So what I'm trying to say is, okay, so over here I've drawn a graph. Okay, let's visualize this. So we see this graph y equal to fx. It intersects at a point between x equal to 1 and x equal to 2. Okay, and if you can see here, the y value of some sort, yeah, of x equal to 1 gives us a positive value. I mean, a positive y value, if you can notice. All right. However, at x equal to 2.0, it gives us a negative y value. So that shows us that the graph has somehow, like went down and has, crossed the x-axis at a point. And that point is between these 2 points because there's a sign change. All right. If there is no sign change, that means no root between those 2 points. Because if the graph was, let's say, a positive and you get a positive value, the graph is not going to, go down the x-axis. It's just going to, somewhat be up here. So there's going to be no intersection with the x-axis. And same thing, if both are negative, let's say here is negative, there's going to be no intersection with the x-axis. So in order to have a root between two specific points, there needs to be a sign change. Right? So that's pretty, that's like about 70 or 80% about this topic. There is another part of this topic where questions will ask you to draw a graph to show the root. However, in this video, I will not cover about the drawing of graphs. However, I'll just focus on, solving the calculus questions in it. Okay, so that's all we have to do. And let's jump into some questions. And by the way, just for reference, I got these questions from a website called pastpaperpenguin.com. So yes, I downloaded the topicals from here. So if you'd like, I just want to, shout out this website. Okay, so if you guys are like looking for any topical questions, go ahead and search up this website where you can get their free topical questions and pause your questions. Okay. All right, so let's jump into our first question over here where we have a graph. Okay, the diagram shows the part of curve x squared is equal to cos 3x for x is between 0 and pi over 6 and its maximum point M where x is equal to a. So we have a graph here, and at its maximum point we have a x value of a. All right, we have an x value of a. Okay, that's good. So show that a satisfies the equation of a equal to 103 tangent inverse of 203a. Okay, so what are some information we can get over here? Okay, first of all, point M is the maximum point. So one thing we know for sure is dy dx, or the gradient is equal to 0. So that's like our first step to take to solve this question. And from solving a question, we can rearrange our equation as such. Okay, so first step is to find dy dx or dx. So we are given the equation y is equal to x squared cos 3x. And how are we going to differentiate this? Well, we're going to use the product rule since the two items here are in a multiplication relation. So we're going to call one u and one of it v. So u will be x squared and v will be cos 3x. Okay, and differentiating them, du or dx will give us 2x, and dv or dx will give us differentiate 3 cos 3 will give us 3, And the differentiation of cos 3x will be negative sine 3x, which gives us negative 3 sine 3x. Okay, so now just apply the product rule, which is u dv dx, u negative 3 sine 3x plus v du dx. And I'm just gonna, write here maybe for reference for you guys, so you guys know the formula of this, which is u dv over dx plus v du over dx. So just apply this formula, okay, over here, and you should be able to get it. And okay, so for a fact, we know our second information is knowing that at m the dy dx is equal to 0. So we can just equate this to 0. Okay, I have 3 sine 3x plus cos 3x, okay, 2x. All right, so we're going to solve, for, x. Right now, okay, what's our first step we can do? Okay, maybe I can move this to the other side, okay? So in fact, it will be negative x squared 3 sine 3x plus cos 3x 2x. And moving it to the other side would give me x squared is equal to cos 3x and 2x. Okay. And okay, we can divide the x in both sides. 3 sine 3x x is equal to cos 3x and a 2. All right. And okay, I can see something here where if I divide the sine by the cos, we can get tangent 3x or something, right? So why don't I isolate the two trigonometric functions, okay, at one side? So I'm just gonna put sine 3x is equal to cos 3x times 2. So we're gonna bring this divide here and bring this here. Okay, so sine 3x over cos 3x is equal to 2 over 3x. Okay, and we should be getting we should be getting tangent 3x equal to 2 over 3x. Okay, and the thing is, we want to, because our a is some sort of our x, which later we will, we'll change it. So what I'm going to do is I'm going to bring this 2 over 3 to the other side, which is going to give us, let me see, it's going to be 3 tan 3x, 2 over x. Oh, sorry. Oh, I'm going to bring the x here again. 2 over 3. Am I doing it right? Am I doing this right? Okay, wait, let me just, okay, we have done this here. Oh, okay, sorry. The 3x will be tangent, we'll move the tangent to the other side, which is 2 over 3x, okay? And the 3 just divide by both sides, we'll get 1 over 3 tangent inverse 2 over 3x. Alright, that's nice. And so for a fact that we know that the x value here is the maximum, the x value of the maximum point. X value of max point. So the x value of at the maximum point will be a, right? So we just replace it with a, and we should be getting it like as requested, 1 over 3 tangent inverse 2 over 3a. Okay, that's nice. So we've got our first question done, and now moving on to the second question. Use an iterative formula based on the equation A. Okay, equation in A to determine A corrected 2 decimal places. Give the result of each iteration to 4 decimal places. So over here in this question, they're asking us to, to determine what A is, or what that, the X value at this point is. And we can use the iteration formula to give us our answer that we want. So they told us to use the iterative formula given in A, which will be this one, okay, the one that we found, to get our X value. So as shown earlier, we're going to rewrite this as 1/3 tangent inverse 2/3a. Okay, and if you noticed here, I put an plus 1 because for each iteration we're going to use the previous value. Okay, so for our first iteration, okay, we will be using, okay, wait, hold on, we will be using pi. Okay, so since here we have two limits as shown, right? Like I explained earlier, they give us two limits, so we can use either one limit. We can use 0 or we can use pi over 6. So in my case, maybe I'll use pi over 6. Okay, so the thing is, so we have this value here, right? So for our second iteration, we're gonna sub this value into here, this A value into here. Okay, and I'm gonna put in my calculator. Okay, and I suggest that you convert your calculator to radians to give you an answer in radians. So inverse tangent will give us 2/3 pi over 6. And I got, so they're telling us to give each iteration to 4 decimal places, right? So I'm gonna give it 0.301 and 7. Okay, and our next iteration is, all we have to do is just sub the same value into A, but which will be a bit of a hassle. So why don't we replace that pi over 6 in our calculator with the answer button, if you do have your previous answer. Okay, there'll be a button called answer where just put it in there and press equal again, which gives us 0.3820, and just press equal again each time, so 0.3502, and press equal again, 8503,624, press equal again, you get 0.3576. A7 equals to 0.3595. Now you can see here I did multiple iterations already, so why not, let's just give a check. So they want their answer in 2 decimal places, so we're going to check each of the iteration for the 2 decimal places. Okay, so let's have a look here. Okay, so first we started off with pi over 6, and then we have 0.30, 0.38, 0.35, 0.36, 0.35, and 0.35 again. But if you notice, in the final 3 iterations by the 2 decimal places, it's all rounding off to 0.36. Well, it's 0.362, so this gives 0.36, 357, which gives us 36, 0.359, which gives us 0.36. Therefore, we are approaching a value of 0.36, which is our root, which is A, sorry, not root, which is the value of A. Thus, A5, A6, and A7 all round off to 0.36 to 2 decimal places. I'm just going to dp. Thus, or so, A is equal to 0.36. That's all. So all you have to do is just iterate each value over and over again. Alright? So this is one of an example, of a question they give. So I'm just going to solve one more, another question. So, it's more clarified on the way how to solve this. Okay, so for this question, the diagram shows a curve y equal to third x cos x with the limits of being 0 to 302 pi and its minimum point m where x is equal to 8, somewhat like the first question. The shaded region between the curve and the x-axis is denoted by r. Okay, so show that A satisfies the equation for tangent A or 102A. So it's just like the same question earlier. We're going to find the x value for the maximum point. And our first key information is that dy dx is equal to 0. So we're just going to find dy dx first. Dy dx, where our y is equal to third x cos x. We're going to find our u first, which is x, and our v will be cos x. So our du over dx will be 1 over 2 third x, and dv over dx will give us negative sine x. So we're going to apply the the product rule again, which is u dv over dx plus v du over dx. Okay, so dy over dx will give us third x, and dv dx negative sine x plus cos x and 1 over 2 third x. And for a fact, we know our dy dx is 0, so we're going to put it as 0 equals to third x minus sine x plus cos x 1 over 2 third x. So move this to the other side, we get sine x third x equals to cos x and 1 over 2 third x. And we can multiply each side with a third x to give us I'm just gonna erase this. I hope you guys have jotted it down. So we're gonna get x sine x equals to cos x. Sorry, I meant multiply each side with the third x, by the way. Third x, where we get sine x equals to 1 over 2 multiplied cos of x. Okay, and we can somehow obtain our tangent by dividing here. So tangent x is equal to 1 over 2x, and as we know, our maximum x value for maximum point is a, so we're just gonna replace the x values with an a, so shown. Okay, so now we're going to do b. The sequence of values given by iterative formula. So in some questions they could already give you the iteration formula they want you to use, and some will tell you to use the previous one. Okay, with the initial value of x1, so they already gave us the initial value start with 2, so it converges to a, so it approaches the value of a. Use this formula to determine a correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Okay, so we're going to use the same the formula given here to us, which is pi plus tangent inverse of 1 over 2an. Okay, so our first iteration will be, of course, the first x value, which is 3.000, since it has 4 decimal places. And for a2, we're simply just going to use the formula and put in our calculator. Okay, tangent inverse 1 over 2 and our root, which gives us 3.3067, and then just complete the next iteration by subbing in the answer into your calculator, which gives us 3.2917. The next iteration 3.2923, and the next iteration we get gives us about the same value again as the previous calculation. So if we have a look at the iterations here, so a3 3.29, it remains 29. A4 to 9 also, rounding off to 2 decimal places, and A5 to 9 also, rounding off to 2 decimal places. Thus, A3, A4, and A5 all round off to 3.29 to 2 decimal places. So x will equal to 3.29, or you know what is best? I think it's best to say that a is equal to 3.29. Okay, so that's all of, that's what iteration is. That mainly they give you, to prove a dy dx or something, and then it's just straight up iteration where you just repeat the calculation several times where it converges to a specific value. Okay, so that's mainly it for this video. I hope you found it useful. And again, I would like to remind you guys that I sourced this paper, question paper, from pastpaperpenguin.com. Okay, so you can find a lot of questions there. So that's it for this video. I will see you guys in the next video where I'm going to talk about graph sketching for this chapter. Okay, so thank you guys for watching. I'll see you in the next video.